All right, so I'm going to start with 2013 paper. So this is January 2013. So January 2013, part 1 or part A. When I post the video, I'm going to insert the question in the video as well. All right, so the first question, it says two compounds, and we are given the molecular formula. So we have two compounds, A and B. Compound A is C2H4. So this is number 3, January 2013. So we are focusing on organic chemistry only. Once we are finished with organic chemistry, in our sessions, we will go back to topics like electrolysis, all right, and acid, bases, and salts. So we have two compounds, compound A and compound B. So compound A is C2H4. And compound B is C3H8. So they're asking us to draw the fully displayed structures of compound A and compound B, and ask us to also name compound A and compound B. Just a second. Right. So we have to draw the displayed structures of compound A and compound B, and give the name of compound A and B as well. So before I draw the structure of compound A and B, both compound A and B are hydrocarbons because they consist of only carbon and hydrogen. So I want someone to tell me which of them is the alkane and which of them is the alkene.
Sir, compound A is the alkene.
That is correct. And how did you know that compound A is the alkene?
Sorry, double. So you have 2 carbon and then you have 4 hydrogen. Like double. Maybe understand?
Right. So, right, so you're referring to the general formula. So each whole molecular series has a general formula. So for the alkenes, the general formula is CnH2n, and N represents the number of carbons. So if you have an alkene with 2 carbons, then N, it would be C2H2 times 2, and 2 times 2 is 4. So that will be C2H4. So when you are given a molecular formula for a hydrocarbon and you want to find out if it's alkene or alkane, you look at the molecular formula and see if it matches the general formula for either the alkene or the alkane. Right? So for the general formula again, for the alkene is CnH2n. That means the amount of hydrogen must be twice the amount of carbons. If you look at compound A, the amount of hydrogen is twice the amount of carbon. So we know that compound A is an alkene. And for compound B, that one is the alkane. And the general formula for the alkane, it is CnH2n plus 2. So again, N is the amount of carbons. So we have 3 carbons, N, H, 2 times N, so that is 2 times 3 plus 2. So 2 times 3 is 6, 6 and 2 is 8. So we have a total of 8 hydrogens. So C3H8. So if this was an alkene, C3, the amount of hydrogen would double the amount of carbon. So it would have been C3H6. But here it is C3H8. And therefore this molecular formula here, it matches the general formula of the alkane. So whenever you have an alkane, the amount of hydrogen, it must not only double the amount of carbons, but you must also add 2 to it as well. So C3H8. If you double it, it would have been C3H6 plus 2 more. It would be C3H8. C2H4. If this was an alkane, how many hydrogens would it have? So if you have an alkane with 2 carbons, how many hydrogens would it have?
36.
That is correct. Because 2 times 2 would be 4. So it would be H, 2 times 2 plus 2. So 2 is 4, 4 and 2 is 6. So it would be C2H6. An alkene, if you have an alkene with 3 carbons, how many hydrogens would it have?
6.
Right. It would have 6. So whenever you are given a molecular formula and you want to know if it's an alkene or an alkane, you can use the general formula. But after a little practice, once you look at it, you will know automatically if it's an alkene or an alkane. Because as I said, the amount of hydrogen is twice the amount of carbons for the alkene, and for the alkane, you have to double the amount of hydrogen and add 2 more. All right, so that's that. If you have any question, you can stop me and I will take your question. So the first actual question was for us to draw the display structures of compound A and B. So we have established that compound A is the alkene and compound B is the alkane. And for those of you who are just joining, this session is being recorded and I'm going to upload it to the YouTube channel so you can see it afterwards. Now we know that the functional group for the alkene is a carbon to carbon double bond. Now this alkene, it only has 2 carbons. So therefore, the double bond must be present between the 2 of them. And we also know that carbon always form 4 bonds. At the moment, each line is a bond. So this carbon, it has 1, 2 bonds. And each of them must have 4 bonds. So that means this carbon needs 2 more. Right? You have to be careful to not do this. If you do this, that means this carbon, it would have 1, 2, 3, 4, 5 bonds. But carbon, it does not form more than 4 bonds. So carbon should always have 4 bonds. So you can draw it like this for this carbon, or if you want, you can go ahead and put the bond below. So you can put 1, 2, I can put 1 hydrogen above and 1 below. It is still correct. All right, and this carbon, it also has 2 bonds, so it only needs 2 more for it to make 4. Then we put on our hydrogen. So this is the molecular formula, C2H4. The displayed formula is where we show how the atoms are arranged in the compound. So we actually draw out the bond lines. So each line is representing a bond. So this is C2H4. Now we already established as well that C3H8 is an alkane. And alkane only has carbon to carbon single bonds. So we have 3 carbons. So we draw the carbons first and connect them together by single bonds. So each line is a bond. And again, each carbon must have 4 bonds. So this one at the moment, it is only forming 1 bond. So it needs 3 more. So 1 above, 1 below, 1 to the left. This one has 2 bonds, so it just needs 1 above and 1 below. This one at the end, it only has 1 bond at the moment, so it needs 3 more. And at the end of every line, you will put hydrogens. Right? So this is the displayed formula for C3H8. And this is the displayed formula for C2H4. Now, can anybody give me the name of compound A and compound B?
Sir, ethene.
All right, so compound A is ethene. And compound B?
Propane.
Propane is correct. All right, so when you're going to name the organic compound, you're going to count the amount of carbons present. So the amount of carbons that will give you the name, that will give you the first part of the name. So 3 carbons, it doesn't matter if it's alkene, alkenes or alcohols, 3 carbons, the name of it will start with pro. So once it's 3 carbons, the name will start with pro. Once it's 2 carbon, the name will start with F, ETH. Any, it doesn't matter if it's alkane, alkene, alcohol, carboxylic acid. The number of carbon atoms present lets you know how you should start out the name. So the first part of the name is based on the amount of carbon atoms present. So we have 3 carbon atoms. Whenever it's 3, you start the name starts with pro. Whenever it's 2, start with F. Now, if it's an alkane, the name will end in ANE. That is why it is propane. When it's an alkene, the name will end in ENE. So that is why it is ethene and propane. So for 2 marks, you were to draw compound A and name it. All right, so that is part A of the question. This is number 3A, part I. Let me know whether I can erase the board and move on. Or is anybody writing so I can erase and move on? All right. All right, so for part 2 now, so it's still 3A, part 2. It says state whether compound A burns in air with a sooty flame So it is asking if compound A burns in air with a sooty flame or a clean blue flame. Alkenes burn with, we say that alkenes burn with a sooty flame. And alkanes burn with a clean blue flame. Okay. So that means compound A, which is the alkene, it would have burned with a sooty flame. So for part 2, they wanted to know if compound A would burn with a sooty flame or a clean blue flame. Alkanes burn with a clean blue flame, and alkenes burn with a sooty flame. And compound A is the alkene, and B is the alkane. So compound A would have burned with a sooty flame. For part 3, it is asking us to write a balanced chemical equation for this reaction. So the burning of hydrocarbons in air, that is combustion. All right, so compound A, it was C2H4. And this reaction, the burning, it means we are reacting it with oxygen. What are the products of combustion? Whenever you burn a hydrocarbon, what are the 2 products that should be produced?
Carbon dioxide.
Sir, when it is complete, it is carbon dioxide and water. Incomplete, carbon monoxide and water.
Right. And in this one, it did not indicate if it was excess or not, so it just says write a chemical equation for this reaction. So we're going to do complete combustion. So ethene plus oxygen to give carbon dioxide and water. And we also have to balance our equation. So we have 2 carbons here and 1 carbon here. So what number should I put in front of the carbon?
2.
2. Right. Right. And I have 4 hydrogens here. So what number should go in front of water?
2.
Right. So 2 times 2, 2 times 2, that is 4 hydrogens. 4 hydrogens, and now we have 4 hydrogens here. So that just leaves us now to balance oxygen. How many oxygen is present for the CO2?
4.
Right.
4.
Right. So we have 2 oxygen in CO2 and the 2 in front. So 2 times 2, that is 4. And how many oxygen is present in water?
2.
2. Right. Well, 1 is present, but there's a 2 in front. So 1 times 2 is 2, so that is correct. So we have a total of 4 oxygen here, plus another 2 oxygen over here. That's a total of how much?
6. So 6.
Right. So we have 6 oxygen on this side. So 2 times what will give you 6?
3.
Right. So we'll put a 3 in front. All right. So that is the balance equation for the reaction. Anybody is still writing? All right, so for part B, I'm going to save part B for next class because it's dealing with esters. So I want to explain esters before I actually work the part on esters. So for part B, I'm going to work part B in next week's class. All right, so number 3, B1, we have 2 compounds, an alcohol and an ester. Right? So compound C is not an alcohol, we have a carboxylic acid and an ester. Compound C is the carboxylic acid. And remember the functional group for the carboxylic acid is COOH, right? Written COOH, when you would draw the displayed formula for COOH, it is written like this. So C, double bond O, single bond OH. So for B2, and so this is compound C. Right, so compound B, B part 2, it is asking us to write a balanced equation for the reaction between compound C and calcium. So we know that C is an acid, and when acids react with metal, we will get a salt and hydrogen gas. So this is compound C, right? So you can do it like this: CH3 COOH, and it reacts with calcium metal, right? So when acids react with metal, you will get salt and hydrogen gas. Okay. So the salt form is CH3 COO. Then, all right, so look. So this is ethanoic acid, right? So if the hydrogen comes off, you will get the ethanoate ion, CH3COO minus. The charge on the calcium ion is Ca2 plus, right? So if you are writing the formula for this, it means that just like with the other formulas, right? When you get the calcium ethanoate, you will have 2 ethanoate ion. And you know that when you have a polyatomic ion, you will have to put it inside a bracket. Is that clear? So the Ca2 plus, when you combine it with the ethanoate ion, you would need 2 of these ions. So you have to put it inside a bracket, right? And put the 2 outside. So in calcium ethanoate, you have 2 ethanoate ion, right? So for organic acids, which is the carboxylic acid, the metals comes after. It's not like how you would have calcium chloride, where it is CaCl2, right? Where the negative ion comes after the positive ion. With carboxylic acids, the positive ion comes after the negative ion. Is that clear? All right, so just make a note. When it's an organic acid, sir, go back over that quickly. Right, so let me do one with sodium as well. If the reaction was between ethanoic acid and sodium metal, you would get CH3COO Na. The metal is replacing the hydrogen of the COOH group, right? So you can ignore the CH3 portion. The reaction is taking place at the functional group, right? And whichever metal you are using, it is going to displace the hydrogen. That is why you don't have the hydrogen here. When you add an acid, right, like hydrochloric acid or sulfuric acid, it was the same thing. The metal, so if it was sodium, right, the sodium metal would have displaced the hydrogen, and so you would have gotten sodium chloride. And if it was sulfuric acid, it would have displaced the hydrogen, and you would have gotten sodium sulfate. Now, for the carboxylic acid, it is the same thing. You are displacing the hydrogen, right, of the COOH group. Not any of the hydrogens in the alkyl groups, the CH3 groups. It's specifically the hydrogens of the carboxylic acid group that is getting replaced. Now, when you remove the hydrogen, right, the ion formed here, it has a negative charge, right? Now, if it has a negative charge and your metal, when it is in solution, if it has a 2+ charge, I want everybody to get this. So before I go back to this, let's look. Sodium is Na plus, the sulfate ion is SO24, is SO42 minus. So sodium sulfate is not NaSO4, because remember you switch the numbers at the top. If it's just a sign, then it's 1. So sodium sulfate is not NaSO4 because we have 2 sodium ions. So it is Na2SO4. So it is the same thing now. When you have the ethanoic ion, it is CH3COO minus. The calcium ion, it is Ca2 plus. So that means when you are writing the formula, the 2 at the top, carry it over to the ethanoic ion. That means in this compound that is going to be formed, we should have 2 ethanoic ion. Now, ethanoic ion is made up of carbon, 2 carbons, hydrogens, and oxygen. So to show that we have 2 ethanoic ion, we have to put the ion inside a bracket and put the number outside of it, right? And then you write calcium. Is it any clearer for the person that asked? So it's because the charge on calcium is 2 plus, where you have to put it inside a bracket and the 2 outside. The reason why it's not inside the bracket with sodium is because the charge on sodium is positive, right? So negative, positive, the charges are equal. This is -1, this is +1, so the charges cancel out, right? So all you will have is CH3COO Na. But in the case of calcium, it was 2 plus, right? And this was minus. And the 2 we carry it over to here, which means we need 2 ethanoic ion. So that is why it is inside a bracket. All right, hope that is clear for persons. All right, so when you react carboxylic acids with metal, you will get salt and hydrogen gas. So it will be calcium ethanoate plus. All right, Jay, you can go ahead and ask the question. The person that.
So, sir, basically, they switch charges.
That is correct. Right. And because it's a polyatomic ion, when it's 2 or more, you have to put it inside a bracket. So the name of it, hold on, let's put the hydrogen. So it's salt plus hydrogen gas. Let me jot down this equation. So that's the salt plus hydrogen gas. So it's the metal in the solid state. The acid is aqueous. I know I haven't been putting in my state symbols, but every time you're asked to write an equation, put in state symbols. All right, so always put the state symbols for your equations. So it's acid plus the metal, you get salt and water. For the salts, formed from carboxylic acid. This ion, the carboxylic acid, the name of this salt, right? So if it's ethanoic acid, it's going to be ethanoate. So the acid ends in anoic. So ethanoic. So when it's the acid, it ends in anoic. When it's the acid, it's anoic, it ends in anoic. But when the salt is produced, it ends in anoate. So it's ethanoate. And you put the name of the metal in front. So it is calcium ethanoate. That's the name of the salt. So it's calcium ethanoate. If it was propanoic acid, it would have been calcium propanoate. If it was methanoic acid, it would have been calcium methanoate. So just remember, the acid, when it forms a salt, the name of the acid, it changes from anoic to anoate. All right, so it's calcium ethanoate. That's the name of the salt. Let me just put back the one with sodium. So with sodium, it would have been CH3COONA. So it would have been sodium ethanoate. Alright? And so that's B2. All right, so for part C, it's polymerized.
Sir.
Yes. Go ahead.
Sir.
Yeah.
Can you have a number, please?
You can.
I want to get some passive and show something.
All right. Just a second.
Sir.
Yes, I'm typing. No, all right, go ahead. Is that question you have?
No, it's a number I want, sir. That is all.
Yeah, man. Oh, and the name of the channel. All right, let me type it as well. Let me just search
Sir,
it.
can you send over it again, sir?
Please repeat.
We can send over a number again, please,
Yeah,
sir.
it's in the chat. All right, let me just.
But sir, I can't see it, sir.
It's in the chat. It's in the
It's
chat.
in the chat as well, you know. I typed it. It's here as well. And the name of the channel that I uploaded to, it's, all right, let me type it in here. So the name of the channel that I upload these videos to, I just typed it in the chat. All right, and it's a part of a playlist. So this is not the first class. So the reason why I'm doing participles and alkenes is because we had already covered alkenes and alkenes. So next week we will do carboxylic acids and alcohols. All right, so for part C, for this 2013 paper, it's on polymers. So I haven't done polymers as yet. So I'm not going to work it until we have done so. All right. So I'm going to look at what the June paper has for organic chemistry.
Mr. Ear.
Yes.
Yes, sir. I am a teacher of high school. So
Yes, sir.
I'm just joining to get some different perspective on what you're doing. Do you have any past papers that you
Yes, I
I'm soft copy?
yes, I have.
Okay, I will WhatsApp you.
Sure.
Uh,
Come on, not a problem. All right, so this is 2013 June paper. Let me see if we have anything for alkanes and alkenes. This is mostly polymers. Polymers. All right. That was mostly polymers. All right, let's go to 2014. All right, here's one. All right, so we're on to 2014. It's January 2014. All right, so for part A, so it's number 3 again. So January 2014, number 3, part A. So we have 3 compounds. Compound A, compound B, who can tell me the whole molecular series for compound A in the meantime?
Alcohol.
Alcohol, that is correct. And what is the functional group for the alcohol? What is the functional group for
OH.
right?
OH.
Right. And this compound, what's the whole molecular series for compound B?
Alkene.
Alkane, that is correct.
Alkene.
And the functional group?
Single bond.
Single bond.
Carbon to carbon, right? Carbon. So you must say carbon to carbon, single bond. And what is this whole molecular series?
Carboxylic acid.
Right, carboxylic acid. And which group did you use to know that it is a carboxylic acid?
C double bond O.
That's
Eight,
it.
eight.
Right, so C double bond O, single
COOH.
bond OH, right? So all of this here, all of this, that is the functional group for carboxylic acid. So the compound A is an alcohol and the functional group is OH. So if you're asked for the whole molecular series, it's an alcohol, the functional group, and OH, it is called the hydroxyl group. All right?
Sir, sir,
Yes,
can we get some notes of this in when I text him, sir?
sure. And again, videos are on this site already, where I go through all of this. But I can send you notes as well. So no problem. Right. So this is the alcohol functional group, OH. The name of it is the hydroxyl group. This is the alkane functional group, carbon to carbon, single bond. This is carboxylic acid. So the functional group COOH, right? And we call it the carboxyl group. So the COOH group, it is called the carboxyl group. All right? So it says, state this. So the first question for A, it was to state the name of the whole molecular series to which compound B and C belongs. So compound B, as we know, is the alkane, and C is the carboxylic acid. So for part B says compound A burns with a blue flaming oxygen. Write a balance equation for this reaction. So what is the name of this reaction when compound A burns in air in oxygen?
Combustion.
That is correct. And if it's combustion, what are the two products that we must get?
Carbon dioxide and water.
Right, that is correct. So I'm going to do that equation now. Is everybody finished with what is on the board?
Yes, sir.
All right. Right, so compound A. Oh, let us name let us name compound A. So compound A, it has in 2 carbons and it's an alcohol. So if it has 2 carbons, what should the name of the compound start with?
F.
F.
Right. And alcohols end in anal, so it is ethanol, right? And compound C, it had 3 carbons and it's a carboxylic acid. So if you have 3 carbons, what should the name of the compound start with?
Propanoic.
Probe.
Right, it should start with pro, and since it's a carboxylic acid, it must end in anoic. All right, so it is propanoic acid. Right. And compound B, what is the name of compound B? It has 5 carbons.
Pentane.
Right.
10.
1, 2, 3, 4, 5. It's a single bond when it's alkane. So 5 carbons, it must start with pen, and it's an alkane, so it must end in ane, so it's pentane. All right, wonderful job. So let's move now to the equation. So ethanol, I'm using the molecular formula now. So C2H5OH reacting with oxygen. We know it's combustion, so we must get carbon dioxide and water.
Water.
Right. I'm going to do the pentane as well. So C5H12 plus oxygen to give carbon dioxide and water. All right, so when we're balancing this equation, we're going to balance carbon, then hydrogen, and leave oxygen for last. So we have 2 carbons here. So how many carbons, what number should I put here? Because I only have 1 carbon.
2.
2.
Right,
2.
that is correct. So we move now to hydrogen. How many hydrogens are in ethanol?
6.
5.
So 5 plus this one here, that is?
6.
Right. So don't just look at the one here. Remember to add
6,
this
sir.
one. Right, 6. So we have 6 hydrogen here. So 2 times what is 6?
3.
12.
Right?
12.
Three, I'm three, sir. Three.
Right. Yeah, man. So 2 3 is 6. I'm going to leave oxygen a little. Let's come down here because I want to point out the difference. All right, so we have 5 carbons here. So what number should I put here?
5.
5.
5.
Right. I have 12 hydrogens. 2 times what is 12?
6. 6.
Right. Now for oxygen, how many oxygen do we have here?
5.
10.
10. So we have 2 oxygen in CO2. So 2 times 5, that is 10. And how many oxygen do we have here?
6.
6.
Oh,
Right, so 10
1.
plus 6. That is, now remember, you have 1 oxygen, right? But when the number is in front of the compound, it does not just go for hydrogen. It goes for every atom in the compound. So it's 1 oxygen times 6. Right? So it's 6 oxygen here, and we have 10 here. That's a total of 16.
16.
16.
Right?
16.
Right. And we have 2 over here, so 2 times what will give us 16.
8.
Right. Now let's go
But
back now to
sir,
the,
excuse me, sir.
yeah.
You could have say you divide the side them, no, sir. Like you divide the reactant side by you divide the product side by the reactant, sir.
Sir, must you talk
Like
when
you
you have an odd number?
Hold on, just a second. Let me admit someone. Right. So you're saying like you want to divide 6 over 2? I mean 16 over 2?
no,
So
sir,
that's
no. It's like, sir, you look. It's on the right hand side, sir. You have to divide to see what you get, sir.
all right. So for carbon, which one is that? All right. So tell me what I say.
No,
All
no,
right.
no.
Hmm?
No worries, sir. No worries, sir.
All right. All right.
Sir?
For who said sir? Shaniqua?
Yes.
Yes.
So is any one of the homologous series oxygen react with, you get carbon and
No.
water?
Alkane, alkene, and alcohol.
Oh, okay.
Yeah. All right. Now let me do. All right. Let's look at the alcohol now, right? How many oxygen do we have where we have CO2?
4.
4.
4.
All right. And how many do we have where we have water?
3.
All
3.
right. So that's a total of
7.
7. All right. Just a second. Let me work on the next one before I go to this. Let's do C4H10 plus O2. We're going to get carbon dioxide again and water. How many carbons do we need here?
4.
4, right? Ten hydrogens. So how many hydrogens do we need here?
5.
5.
5.
Right. So in terms of oxygen, how many do we have here?
8.
8.
Right. 8. And how many do we have here?
5.
5.
5.
5.
So 8 and 5, that's a total of 13, right?
13.
So what times 2 will give you 13?
13 over 2.
Right. So 6.5, right? But we cannot put 6.5. So
You
for
will
this
leave a remainder.
equation, we use a fraction. So we know that 6.5 times 2 is 13, but you can just use an improper fraction, which is 2 6 is 12, 12 and 1 is 13. So the improper fraction is 13 over 2. So whenever you have an odd number, right, Just for oxygen, just put it over 2. 13 over 2, that is 6.5. Right? So we just use an improper fraction. Is that clear? So once it's an odd number,
Yes, sir.
just put it over 2, right? For oxygen. Right? So this type of fraction. Yes, go ahead. Yeah.
Sir.
Yes.
I think you're going to times the whole of the equation by 2, sir.
No, you don't need to. That is what I'm saying. Just use a fraction and stop it there. I know some teachers might do it.
But sir, can times it by 2.
Right. But
The
I'm
whole of the
saying,
equation by 2.
right. I know some teachers do it that way on textbooks, but you can just simply use a fraction. It's allowed, right? So you can use a fraction for this type of equation. So instead of going on time means everything by 2, you just use a fraction for the oxygen. All right? It's actually allowed. So the only time you will need a fraction is when the number of oxygen is an odd number. So if it was, let's say, I have 5 oxygen over here, what would you do here for oxygen? If you have 5, 5 is an odd number.
You would have 5
Please
over
repeat the
2.
answer. Right, 5 over 2. So we just need to put an improper fraction. So you don't need to be multiplying everything by 2. Right?
Oh,
So
Mr.
again,
I didn't know that you could use an improper fraction. I normally would have done what the young man said, multiply out by 2.
2, right? No, well, I use the fractions, right?
Well, this is something new. I'm learning something new.
Oh, yeah, man. So, yeah, a fraction we use, right? So, whichever way you prefer, all right? So, it's not a problem. So, you can go ahead and multiply by 2, or you just go ahead and balance the oxygen with an improper fraction, all right? So, whether you want to use the mixed fraction or the improper fraction, but fractions, it's just the fraction is just for this particular equation. All right. All right. So the reason why I was doing this is to get back to the alcohol now. So if you look over here, right, we have 7 oxygen. Now I just told you that if you have an odd number for oxygen, all you need to do is come here in front of this oxygen on the reactant side and put it over 2, and everything is okay. However, you have to bear in mind that the alkane or the alkene, it does not have any oxygen. All right? If you come to the alcohol has in an oxygen. All right? The importance of this, what this is going to do is drop this number by 1. So you have 7 oxygen over here. You cannot come here and put it over 2. If you do that, all right, so let's say put 7 over 2. We know 7 over 2 is 3.5. So 3.5 times 2, that is 7. But this oxygen would mean that you have 8. All right? So what I tell my students to do, when it's an alcohol, any amount of oxygen you calculate on this side, you have to take away 1 from it. So if we calculate 7 oxygen for this side, to account for the oxygen in the alcohol, you are going to take away 1 from it. So if the total over here is 7, and you take away 1 from it, how many do we have remaining? 6. So we calculated 7 oxygen as the total, but we have to account for the oxygen in alcohol. So 7 minus 1, that is 6. So once you account for the alcohol oxygen, then the regular rules apply. So 6 is an even number. 2 times what will give you 6?
3.
Right. So it's 3 oxygen. All right. So the difference between the alcohol and the alkanes or alkenes is that the alcohols has in an oxygen atom. So you need to account for it before you balance this oxygen here. So on this side, we have 7 oxygen. So, and we also need to have 7 oxygen on this side. But you have to remember now, we have oxygen here and we have oxygen in alcohol, right? So account for the oxygen in the alcohol, and then whatever else is needed, you will balance it with this oxygen. So we got 7 oxygen on this side. So to account for the oxygen in alcohol, we subtract 1. So that leaves you with 6. So we need to convert, basically get this oxygen to 6. And so 2 times 3, that is 6. And if you check it now, 3 2s, that's 6 oxygen, plus this 1 oxygen, that's a total of 7 oxygen. Is that clear? Everybody okay with that?
Yes, sir.
All right, let's work on next one. All right, so this one is for the past paper, right? But let's just work on next one. All right, so again, we have 3 carbons here. So how many carbons do we need here?
3.
3, right? So in alcohol, how many hydrogens do we have?
8.
8. So 7 here plus the 1, that is 8. And 2 times what now will give us 8?
4.
4, sir.
4. Right. Let's move on to the oxygen now. How many oxygen do we have here?
6.
6. All right. And how many do we have here?
4.
All right. So 6 and 4,
With a
that
4.
is 10. Right. Now, how do we account for the oxygen in alcohol? What should we do to the 10?
-1.
Minus 1. So if we minus 1 from the 10, that leaves us with how much?
9.
9.
9.
Right. Now, 9 is an odd number. So what do I do? What do we do with odd number for
Sir,
oxygen?
put it over the 2. 9 over the 2.
42. Right. So just look for alcohols. If it happens again, when you get an odd number for alcohol and you account for oxygen, it is going to change it to an even number. So you won't need a fraction. So in the case of alcohol, when you get an odd number and you account for the oxygen in the alcohol, that is going to change it to an even number, right? That is why you did not have a fraction here. However, if you get an even number, when you account for the oxygen in the alcohol, it is going to change it to an odd number. And that is where we use the improper fraction. All right? So, all right, so those are the 2 examples. You want to try one for yourself or we'll move on? Which one I want to do?
So try one.
All right. So it's alcohol. So let's go to C4 now. So C4H9 OH plus O2, and I get carbon dioxide and water. So you can try it after a minute. You can tell me your answer. So just so that everybody can get a try, after a minute, then you can go ahead and start telling me your answers. All right, if anybody has an answer at this point, you can go ahead and tell me.
Sir,
Yes,
so you ready?
yeah, ready.
So in front of the carbon, there should be a 4.
All right, we'll put a 4, that is correct. And
And
in front
in
of the
front of
hydrogen,
the 5, sir.
that is also correct.
So, sir, you're going to get 9 oxygen and you're going to take away 1, leave 8.
Wait, 9 oxygen, you forgot to account for
Oh, Jesus.
the 5,
13. Sorry,
right?
13. And you take away 1,
Right,
which going to get 12.
right,
And divide that by 2, which
right.
is 6.
Wonderful. Good job, Tanoya. All right, so that's very good. All right, so this question, so part C is on solubility. So I'm just going to use a portion of next week's class to explain the solubility of organic compounds, because one in 2013 was also asking about solubility with esters. So I'm just going to use a portion of the class and talk about solubility. All right, so for part C, we're going to do that in next week's class. And their reactivity. All right, so the rest of this question is talking about solubility and the reactivity of compounds A and C, right? Now we haven't done that, so I want to explain it first, and then we can attempt the questions. So these questions, I'm going to save them for the last part of next week's class after we look at these functional groups. All right. So that would have been January 2014. So let me see question 5. All right. It's now, let me see, let us work one more and then we call it. All right, so here we go. This is 2014 June. All right, this is more, yeah, strictly alkanes and alkenes. So you should be more familiar with this one. All right, so June 2014, number 3. So it's about isomerism. So the first part asks us to define isomerism. So what are structural isomers? Can anybody tell me? What are isomers?
Sir,
Go ahead.
sir, isomers as the same molecular formula but different arrangement of atoms.
Right, so compounds with the same molecular formula but different arrangement of atoms. Now the arrangement of the atoms, that is basically the structural formula. So you can also say compounds with the same molecular formula but different structural formula, because the structural formula, it shows the arrangement of the atoms. So if the structural formula is different, it means that the arrangement of the atoms are different. So you can say different structural formula as well if you want. All right. All right, so we're given two molecular formulas, and we're going to do as they have the same molecular. Right, so Michaela had texted same molecular formula, but different structural formula, which is correct. All right, so let's do the actual join of the isomers. All right, so before I do the one on the question, right? Just remember, all right, so let's look at C5H12. Whenever you get a molecular formula and you want isomers, any amount of carbon that is present, just draw them out in a straight line. So 5 carbons, 1, 2, 3, 4, 5, right? Just draw it in a straight line. Put on your hydrogens. So this one is pentane, right? But don't leave it like this, always put on your hydrogens, right? And most students tend to think that this is not an isomer. This is a part of it, right? So when you are given a molecular formula, an amount of carbon is present, just draw it out in a straight line. If you want to get a second isomer, the carbon at the end, you are going to remove it. Because remember we said the arrangement of the atoms must be different. Now, if you remove this carbon, how many carbon atoms remain in the chain?
Sir, 4.
4.
Sir.
Right, so the new compound would have 4 carbon atoms in the chain. Now, when we say we are changing the arrangement, we don't mean we don't mean draw a line, come down and put the C there. The arrangement did not change.
Sir,
Yes, go ahead.
excuse me, sir.
Yeah. I'm listening. You can go ahead.
No, because I couldn't see.
Oh, you, are you seeing it
I
now?
didn't see. I didn't see the table, sir. Yes, sir. Yes, sir. Yes,
Just,
sir.
hold on. You, please, are you saying you did not hear what I just said? You want me to repeat?
No, no, sir. No.
All right. All right. So after you draw the 5 carbons in a straight line, you're going to remove the one from the end. But students tend to think that changing the shape of the molecule means that it's a different structure. Remember, we said we have to change the arrangement, meaning how the carbon atoms are connected. So we have to change how they are connected. Just a second. Yes, right. It should have, right, 5 carbons and 12 hydrogens. Now, if you do it like this carbon here, if you turn it down, let me give this carbon a letter. So this is carbon A, right? This is still carbon A, and this carbon here, it is still attached to carbon A, right? Are you seeing what I'm saying? Even though
Yes, sir.
even though they look like they are different, they are connected the same way. Because this carbon, when it looks like this, it is still attached to carbon A. So that means it should not be on this carbon any at all. All right? It should not be on this carbon any at all. Now, if you come out to this end of the carbon and put it there, you are going to get it incorrect as well. Because when you're counting the chain, you count the longest continuous chain. Meaning, if you're counting 1, 2, 3, 4 carbons, right? This carbon is not the end because this one is connected to it. So this carbon is the end. So if you were counting, you would say 1, 2, 3, 4, 5, and 5 carbon is pentane. So what I'm telling you, when you take off a carbon atom, do not put it at the end of any of the carbons. So when you take off this, do not put it on this carbon at the end, do not put it on this carbon at the end. Put it on one that is in the middle. So you'll put it on this or this. Right? Now, if you have 4 carbons in the chain, right? Because this carbon here, it is not a part of it. So this right here is like the main road, right? This is the main chain. This carbon is clearly not a part of it. So it is a branch. So how many carbons are in the main chain? How many?
Sir, 4.
4.
4, sir.
4. 4, right. So 1, 2, 3, 4. Now if it's 4 carbon, what is the name of that alkene?
Sir,
Butane.
butane.
Butane is correct. Right? So you have to count the carbons in the main chain. So you have to ignore this one. Now this group here, this CH3 group, it's a branch. And when the CH3 group is a branch, what is it called?
Methyl.
Right. So this CH3 group here is called methyl. So it is methyl butane. All right. So again, if you look at this, this is
Sir,
CH3. Yes?
what about the
The
position?
position.
Come on, I'm not finished. I'm not finished. Yeah. I'm just going to explain something again. So I said that this CH3 group, it's called methyl. But if you look at this one, right, it is also CH3. Why isn't this CH3 group called methyl?
Yeah, because it's in a straight chain.
Right, it is a part of the chain. Right, so I just wanted to make that clear for other students. This CH3 group, it is not a part of your chain here. It is attached to it. That is why we say it is a branch. So when the CH3 group is a branch, that is what we call it methyl. This CH3 here, it's a part of your chain. So we cannot call it methyl because we counted that carbon atom as a part of the chain in order to get butane. This was not counted because it was not a part of it. So it is methyl butane. And remember now, as some of the students were saying, we have to tell where the methyl group is. So which carbon atom is the methyl group attached to?
Or the second one.
Right, the second carbon, that is correct. So it is 2-methyl butane, right? That is correct. So pentane, so C5H12, it has three isomers. It has pentane, 2-methyl butane. I'm going to draw the third one now. All right, so I'm going to erase this one at the top. Now, what you're going to do is remove a next carbon atom. All right, so if we remove a next carbon atom from the end, how many do we have left in the chain?
3.
Three. All right, so 3 carbons are in the chain. Now, when you take off this carbon, can we put it at any of the end carbons?
No, sir.
No,
No,
sir.
it must go
Between and
here
middle.
in the middle. All
Middle.
right. So one will go above and one will go below it. All right. And you can put on your hydrogens. All right. So 3 carbons are in our main chain, right? So 1, 2, 3 carbons. What would be the name of that alkene? It is 3 carbons.
Propane.
Propane. All right. Can I erase this one?
Yes, sir.
All right. So it's propane. All right. Now, let me just put on the hydrogens on these. So this is a methyl group, correct?
Yes, sir.
All right, so we have a methyl group there. And we have one above it as well. All right, can't get to put on the hydrogen. So we have 2 methyl groups. So it is methyl propane. Now, when you have 2 of the same groups attached, what should we do?
You're
Use
gonna
the
add dye.
prefix dye.
Right, di. So it is dimethyl because we have 2 methyl groups. You're not going to put 2 methyl because remember 2 indicates the position. So to indicate that you have 2 methyl groups, you must put dimethyl. If it was 3, it would be tri, and 4 is tetra. All right, so we have 2 methyl groups, so it is dimethyl propane. Now, this methyl group, which carbon is it attached to?
Second one.
The second
Sir,
one.
can you write them on the board for me, please?
Please repeat.
Can you write them on the board for me, please?
The right, exactly. The name of the isomers. Please repeat.
Yes, sir.
All right. After I finish this one, right? So this methyl group is attached to carbon 2, and this one is attached to which carbon?
2 as well.
right? So it is 2, comma, 2. So even though both of them are attached to carbon 2, you still have to write it 2 times. So it's 2 for this methyl group and the next 2 for this methyl group. So both methyl groups are on carbon 2. And you use a comma to separate the numbers. Alright? So it's 2,2-dimethyl propane. So C5H12, it has 3 isomers. We did 2 already. So the 3 isomers of pentane, so we still have the straight chain, which is pentane. We have 2-methyl butane, and here we have 2,2-dimethyl propane. So these are the 3 isomers of pentane, or C5H12. So even on the exam, if you're asked to draw the 3 isomers of pentane, you will still draw the straight chain, right? As well as this one and this one. Now, the reason why we cannot get any more isomer, right? If you should take off a next carbon from this, how many would remain?
2.
2.
2, right? Now, the main chain, it must always have more carbons than the amount of carbons that are attached. So if you look, the main chain here, it has 3 carbons, right? And 2 attached. Now, if you should take out the next one, that means the chain would be shorter, right? Than the amount, right? So what will actually happen? You will actually be joining back a structure that you have drawn before. So if you want to know when to stop, your chain should always be longer than the amount of groups that are attached. It should not be equal, it should be greater. If we go any further, the chain is going to get shorter. It means the chain has only 2 carbons and you must attach 3 to it. So it wouldn't work. Alright? So the 3 isomers of pentane, which is C5H12, again, you must draw the structure for pentane, 2-methyl butane and 2,2-dimethyl pentane. No, that was not the first paper question. I was just revising it. Let me quickly find it. Right, so we got C4H10. So in the space provided below, draw isomers of C4H10. So I just did C5H12 for you. I'm going to give you 2 minutes and you try and do C4H10. Now all you have to do is do the same thing I showed you. So the molecular formula is C4H10. Draw 2 isomers for C4H10. Remember, every structure you draw, it must add up back to the molecular formula. So in this case, let me just put the hydrogens on it. So we have a hydrogen here, and one above. So 5 carbons, 3 hydrogen here, 3, 6, 9, 12, C5H12. So any structure that you would draw, it must add up back. Right, butane is one of them. So C4H10, butane would be one. Yes, Tanai?
And 2-methyl propane.
That is correct. So it is butane and 2-methyl propane. So let me do that one quickly. So C4H10. So again, you just draw the 4 carbons in a straight line and put on your hydrogen. Alright. And that is 4 carbon, that is butane. And so if you did like I showed you and remove this carbon, you would have 3 remaining. And we should know that we cannot put it at any of the N carbons. You would put it on a carbon in the middle. Alright. Alright. And so the chain has 3 carbons, so we know that that is propane. This carbon here, this CH3 group, is not a part of the chain, so it is methyl propane. And it is attached to the second carbon, so it is 2-methyl propane. So the carbon, so the 2 isomers, we draw the straight chain, which is butane, and the next one is 2-methyl propane. So those are the 2 isomers, and this was worth 4 marks to draw these 2 structures and name them. Well, it did not ask for the name, so it was 4 marks just to draw the 2 isomers. Alright, so for part B, it gave us an alkane and an alkene. I can erase the board. Everybody good?
Yes, sir. Sir.
Yes,
Alright.
sir.
Alright, so we have this alkene. Can you tell me the name of this alkene? It's 3 carbons.
Is it propene?
That is correct, propene. And then I have this. What is the name of this compound?
Propane.
Propane. Correct.
Propane.
Right. No, they are asking us for describe briefly one test that could be used to distinguish between compound A and B. So remember when we did the reactions of alkanes and alkenes, there are 2 reagents that you can use. You can use potassium permanganate and you can use bromine water. All right. So if you want to distinguish between an alkane and an alkene, you can use potassium permanganate or bromine water. All right. And in terms of observation, the alkene will decolorize both of them. So alkene will decolorize KMnO4 and bromine water. All right. So it will decolorize both of them. But for the alkane, it will not. All right. So the alkane, for the potassium permanganate, you will have no visible reaction. So if they ask for observation as was done here, if you add the potassium permanganate to the alkane, no visible reaction will occur. No visible reaction. All right? Or you can say that the potassium permanganate, it will remain purple. All right? Now, for the bromine in water, right, it can react with alkane, but under what condition will bromine react with alkanes? Anybody remember?
In dark
UV
room.
light. That is correct. UV light. So, just to recap, you can use potassium permanganate or bromine water. The alkene will decolorize both of them, right? They will go to colorless, right? Now, for the alkane, it will not react with KMnO4 any at all. But for the bromine water, it will react with it if UV light is present. So if you carry it outside and do it in sunlight, it will take place, right? Because sunlight, it has UV light as well, right? So all you would do is just add a few drops. So in terms of a test, just add a few drops of KMnO4 to the compound A or compound B, right? To both of them. Compound A is the alkene, compound B is the alkane. So just add a few drops of KMnO4 to compound A and B. For your observation, compound A would decolorize the potassium permanganate, and compound B, which is the alkane, no visible reaction will occur. That is if you want to use KMnO4. If you want to use bromine water, it's the same thing. Just add a few drops of it to a small amount of compound A and compound B, right? In the absence of UV light. So you will not do this one in the presence of UV light. And so for your observation, as I stated, the alkene will decolorize the bromine water and the alkane will not. So these are the two tests that you will use. Well, you can choose any one of them if you're asked to differentiate between an alkane and an alkene. Ready again? I can erase.
Yes, sir.
All right. So for B2, it is asking us to write a balance equation for the burning of compound B in excess oxygen, which is combustion. So B2, let's do that quickly. So it is C3H8 react with oxygen to give CO2 and water. Now the reason why they emphasize excess oxygen here is because if the oxygen supply was insufficient, instead of carbon monoxide, you would have gotten carbon. Instead of carbon dioxide, you would have gotten carbon monoxide. So when enough oxygen is present, we have complete combustion. But if it was insufficient, it would have been carbon monoxide. Correct, Mikhail. Yeah, Mikhail. All right, but they said it was in excess, so it is CO2. So all we need to do now is balance our equation. So we know that we should put 3 there. What number should go in front of the hydrogen?
4.
4.
Right. And so how many oxygen do we have here?
6.
6.
All right, how many oxygen here?
4.
And
4.
6 and 4, that is
10.
10.
10.
All right. So 2 times what will give us 10?
5.
5.
Right. So that is your balanced equation. So B3, it was asking for a use of alkanes and alkenes. So alkanes are used predominantly as fuels and alkenes for plastic. But when we do polymers, you will realize why we say that alkenes are used to make plastics. All right. But just like you know, butane, propane, we know that those are used as fuels. All right. And then after that one, where was I? All right. So the final reaction now is a reaction of alkenes. I can erase this as it.
Yes.
No,
All
sir.
right. Let me know when you're finished. In the meantime, how do we convert an alkene to an alcohol? Anybody remember? What would we react an alkene with to get an alcohol?
You can erase.
Sir, can you say the excess use of sulfuric acid?
No, this sulfuric acid is a catalyst. What would you add to the alkene? All right, do you remember the name of the reaction in which you convert the alkene to the alcohol? If you know the name of it, it's hydration. So if it's hydration, what do you think we are adding to the alkene?
Hydrogen.
No. If it was hydrogen, it would have been hydrogenation. What does hydrate mean?
Oxygen.
If you are hydrating,
Water.
water is correct.
Water.
Miss, water.
Right. And Michaela,
Water, sir.
Michaela's texted it as well. Right. So for part C, they gave us the alkene and they draw the structural formula. Right. And we react it with compound X and we get the alcohol. So the question was identify X. So we know that X is water. So what happens is that the double bond, it breaks, right? The OH comes here, and the next hydrogen of water comes to this carbon. So water is H2O, one hydrogen. So the hydrogen goes to the carbon of the double bond with more hydrogens, right? So that is why the hydrogen came here, and the OH went to the carbon in the middle. The hydrogen, just like with HBr, if you're adding HBr, the hydrogen goes to the carbon of the double bond that has more hydrogen. So this is where the double bond was, right? This carbon has 2, this carbon has 1. So because this carbon has more hydrogen, that is where you put the hydrogen, and this carbon is where you put the OH. Right? It says state the name of compound D. So what is the name of compound D?
Or is it propanol?
Propanol.
Right.
But
Yes, and which carbon is the OH group?
Sorry,
Second.
the second.
Right, so it is 2-propanol, or if you want to say propan 2-ol. All right, so you can say 2-propanol or propan 2-ol. So it asks for the name and the whole molecular series. So what is the whole molecular series?
For alcohol.
Alcohol, right? So the whole molecular series is alcohol, and the name is 2-propanol. All right. So next week I'm going to go through the reactions of alcohols and carboxylic acids. Right. And if we have time, hopefully, we will be able to do polymers. All right. But definitely alcohols and carboxylic acids. We should have enough time because it's 2 hours. Right. So I'm going to end here for this class.